everyone, and welcome back to the new video of this channel. So today we will be solving a problem which is a special array with x element greater than or equal to x. So it's a Leetcode 1608 problem and easy level problem. So let's see the problem statement. So before moving forward in this video, please make sure that you have liked and subscribed to this channel. And also it's my advice to all of you that please read the problem and try to build up the intuition. Then try to do the code. Then it will be beneficial for you. So let's read the problem. So problem is saying that we have given a array nums of non-negative integers. Nums is considered special if there exists a number x such that there are exactly x numbers in nums that are greater than or equal to x. So it is a confusing statement. I will tell you about how we'll solve this and what is the mean of this complete statement. So notice that x doesn't have to be an element in nums. Return x if the array is special, otherwise return -1. It can be proven that if nums is special, then value of x is unique. So it has been asked by many companies like Amazon and Microsoft. That's why it is a very intuitive question actually, because this statement is very important for this x such that there exist exactly x numbers in nums that are greater than or equal to x. I'll tell you about how we will solve this problem. So let's see the examples, like directly see the approach for this problem. So we have given that number of elements that are greater than equal to x should be equal to x. Like a number of elements greater than equal to x that are equal to that should be equal to x actually. So what we will do, we have given first example is 3 comma 5, nums is 3 comma 5. So what we will do, firstly what we will do, we will simply sort the array 3 comma 5, then 3 comma 5 will be same as it is. Now what I will do, I'll check, like I'll traverse from the back and I will keep a count integer, sorry, and initially count will be 0, and I'll check like if nums of I is greater than equals to count, then I will increase my count. Here you can see 5 is greater than equals to 0 because initially count will be 0. So 5 is greater than equals to 0. Yeah, my condition is perfect. So I will increase my count plus plus. Now my count is 1. Here the count is 1. Now I'll go forward. Actually I am traversing from the back, so I'll go forward, and now I'll check like if my count is greater than equals to, if my nums of I is greater than equals to count. Here nums of I is 3 and 3 is greater than equals to 1. Yeah, this condition is also true. So in that case also I will increase my count. Now count will be 2. Here the count is 2. Now my array is empty, like I have traversed completely. So I've after this I will simply return my count. Here the count equals to 2, so 2 will be my answer. So how we are doing this? Why we are traversing from the back? Why we are not traversing from the starting? Because you see, we have sorted the array, and after sorting, the greater element will be at the right position, means ending position, ending index. So what I will do, I will simply check, like here you can see the number of elements greater than equals to x should be equals to x. Actually the mean is of this statement is, if I am taking a count initially the count is 0, if I am taking the count, that should be greater than or equal to, sorry, the count should be less than or equals to my nums of I. If here the nums of I is 5, you can see here, so 5 is greater than equals to my nums count. So in that case I can increase my count. Otherwise I have to simply return -1, or I have to simply return the size of the array. That depends on the condition. I will tell you about this. Here the second example is 0 0. After sorting, we will get 0 0 again, and now initially count will be 0. So now I'll check like if count is greater than nums of I. No, it's a wrong condition, so I'll simply return -1, because my condition is if my nums of I is greater than equals to count. If my number is greater than equals to count, in that case I will increase my count. Otherwise I will check like if my count is greater than nums of I will simply return -1. I will see this example, because this example will clarify all the doubts regarding this question. Like we have given this example, you can see here 0 4 3 0 4 3 0 4. After sorting, what I will get, I'll get this 00344. Now we will traverse from the back, and I will check like if initially my count will be 0. Now I'll check like if my number, if my nums of I that will be a number is greater than equals to count. Yeah, because nums of I is 4. 4 is greater than equals to 0. In that case, I will increase my count. Now count equals to 2. Now count equals to 1 actually. Now again I will check like if my nums of I is greater than equals to count. Count is 1. In that case also I can increase my count. Count equals to 2. Then again I will check like 3 is greater than equals to 2. Yeah, this condition is also perfect. So now count will be 3. Now I have to check like if I have to check like if my nums of I is greater than equals to count. 0 is greater than equals to 3. No, it's a wrong condition. So it's a breaking condition. This count equals to 4 doesn't happen because this will not happen because you can see here our condition is wrong. You can see our condition is if my nums of I is greater than equals to count, then in that case I can increase my count. Here, the nums of I is 0. That is greater than or equals to 3. No, it's a wrong condition. In that case, I will not increase my count. Here, count equals to 4 doesn't happen. And it's a breaking condition. So, I'll stop here and I will check like count 1, 2, 3. 3 will be my answer, desirable answer. So, here the answer will be 3. Now this is the most optimal example, means this example will clarify all the doubts like 03677. Initially I'll check like nums of I is greater than equals to count. Yeah, 7 is greater than equals to 0. So in that case I will increase the count. Count equals to 1. Then again I will check like 7 is greater than equals to 1. Yeah, if condition is also perfect. So count equals to 2. Now 6 is greater than equals to 2. Again count equals to 3 because I have to increase my count because my condition is true. Okay. Now again I will check like if nums of I which is 3 is greater than equals to 3. Yeah, this is perfect condition because I can take either the greater element or equal to element. I can't take the less than element. So 3 is greater than equals to 3. Here you can see nums of I is greater than equal to count. That is a perfect condition. I can increase my count. Count equals to 4. Now again I can check like 0 is greater than equals to 4. No, it's a wrong condition. I have to stop here. So this was a complete approach for the particular question. Now the code is very simple. What I have done is I have simply done my sorting technique. Firstly, I have to sort. Now what I do, I have to traverse from the back, for loop from the back, and now I'll check like if my nums of I is greater than or equals to count. That is the perfect condition. So in that case, I can increase my count plus plus. And साथ की साथ क्या चेक करना पड़ेगा? If my count is greater than nums of I, अगर किसी condition में मेरा count greater than nums of I हो जाता है, so in that case I have to return -1. And in else condition, return count. Because if this condition is not true, means nums of I is less than count, in that case I have to return my count. Here you can see here the 0 is greater than equals to 3. No, it's a wrong condition. So in that case it is a else condition. Nums of I is less than count. Nums of I is less than count. It's a else condition. I have to return my count. In that case I have to return the count. The count will be 1 2 3. 3 is the my count. So I have to return my count. And in when my complete loop has run, so in that case I have to check like if my complete loop is run and there is no breaking condition, there is no any other condition that we have to check in this loop. So after that I have to return my size of the array, that is equal to if my complete loop has run. You can see count equals to 1, count equals to 2, आगे कोई elements नहीं है, so there are no elements, so I have to return the size of the array, that is equals to 2. Because either you can return the count or you can return the size of the array. Size of the array is the complete array size because I have traversed the complete array. Now no elements will be there, so I have to stop there in the at that condition. So now let's do the code for this. So coding part, I told you about this. Coding part is very simple. Code in that code, what I've do, like I have to apply int count equals to 0. Initially count 0 रहेगा and int n equals to nums dot size. ठीक है. नाउ आई हैव टू सॉर्ट द एरे, सो सॉर्टिंग कैसे करेंगे, नम्स डॉट बिगिन करके, सॉरी, कॉमा, nums dot end. So by using this, I have sorted my LE. Now what I will do, I have to simply traverse from the back. So for int I equals to n minus 1 to I greater than equals to 0, then I minus 1. I am traversing from the back and I'll check like if my nums of I is greater than equals to my count. Yeah, that is the perfect condition. I have to increase my count here and साथ के साथ क्या check करना पड़ेगा, if my count is greater than nums of I. अगर मेरा काउंट ही नम्स ऑफ आई से ज्यादा हो जाता है, इन दैट केस आई हैव टू रिटर्न -1, एंड इन एल्स केस आफ्टर दिस, इन एल्स केस आई हैव टू रिटर्न माय काउंट, बिकॉज साथ के साथ मेरे को काउंट भी रिटर्न करना पड़ेगा। एल्स केस में यू कैन सी दिस एग्जांपल हियर, what I have done is here the count equals to 3, and after this condition I'll check like 0 is greater than equals to nums of I. No, it's a else condition because 0 is less than 3, which is my count. So 0 is less than 3, it's a else condition. Else condition में क्या होता है, मेरे को रिटर्न करना पड़ता है काउंट को, जो कि काउंट 3 है, तो 3 रिटर्न मेरे को करना पड़ेगा। That was my answer also. You can see here 3. And after this, when my complete loop has run and there are no breaking condition, so in that case I will simply return n. So that was the code. If I run this code and see if this will work or not, yeah, it is working perfect. You can see here it is. Now let's submit this code. Hmm. You can see here it is taking 5 millisecond time. That is a perfect condition for this. Means it's a good approach. There will be some optimal approaches also. You can use binary search here, because the technique to use binary search is, you can see here, we have to find the greater elements. Greater or maximum, greater max, you have to maximize the array, minimize the array, you have to find the greater element in the array. So these are the key points for the binary search. You can see here we have to find the greater than or equal to x, so we can use binary search here, and it's a very simple approach to use the binary search here. You can do by yourself also, and if there will be some doubts, you can comment. I will tell you about the binary search also if you want. And here the time complexity and space complexity is very simple. You can see here the time complexity is big of n log n, because we are sorting the array, and big of n because we are traversing the array. So big of n log n plus big of n will be the time complexity, and space complexity will be big of log n, sorry, because for sorting purpose the space will be required. So the space complexity is big of log n, plus somehow I am just copying my data, so I can take big of n also. It's not necessary, but I can take big of n also. So big of n log n plus big of n is the time complexity, and big of log n plus n is the space complexity for this question. So this was the code, and if you find this helpful, then please like, share and subscribe. तब तक के लिए bye.